Hello friends, in this video tutorial we will learn how to design the beams, RCC beams, or design steps for RCC beams. Firstly we will study how to calculate the load on beam and then how to design the beam. What is the procedure? IS code used is IS 456. So calculation of loads on the beam for design is as below. Step 1. Take half the slab from both the side of beam and calculate volume per meter width. Multiply it with density of the concrete. Here you will get uniform load on the beam by the weight of slab. Now consider dead weight of the beam and add to the above weight obtained. Now you have your beam with uniform dead load, uniform point load acting on it. Use bending moment diagram to obtain maximum bending moment and shear force diagram to obtain maximum shear force for which you are designing the beam. In further slide we see the procedure of design of RCC beam with practical example. Here we see the example. A simply supported RC beam has an effective span of 6 meter. UDL uniformly distributed load on beam is 30 kN per meter excluding its self weight. The cross section of beam is 300 mm wide and 625 mm deep overall. The reinforcement consists of 5 bars of 25 mm diameter. Out of these, 2 bars are curtailed. Design suitable shear reinforcement for the beam. Permissible stress in steel and concrete are 140 MPa and 5 MPa respectively. For this we need to design a beam. So now solution. Effective cover is equal to clear cover plus half the bar diameter. So effective cover is 25 plus we are using 25 mm bar diameter, so 25 divided by 2 is equal to 37.5 mm, say 40 mm. So effective depth is equal to overall depth minus 40 is equal to 585 mm. Self weight of beam per meter length is equal to 0.3, it's a depth 0.625, overall width of beam into per meter width, so 1 into 25 is the density of concrete, so 4.69 kN per meter is the self weight of beam per meter length. So total UDL is equal to 30 whatever given in the problem plus 4.69 which is equal to 34.69 kN per meter. Now maximum shear force is at support, which is V is equal to W into L divided by 2, which is equal to 34.69 into span of beam is 6 meter divided by 2, which is equal to 104.10 kilonewton. So nominal shear stress is equal to V divided by VD. V is a 104.1 into 10 raised to 3 Newton divided by 300 into 585. Here D is the effective depth. So 0.59 Newton per mm square nominal shear stress. Now calculation of permissible shear stress. Percentage of tension steel is equal to AST upon BD into 100, which is equal to 3 into pi by 4 into 25 square into 100 divided by 300 into 585 is equal to 0.84. This is percentage of tension steel. We are calculating. This formula is given in IS 456. Here concrete grade of concrete is M15. Now use table number 24 of IS 456, percentage of steel reinforcement and permissible shear stress. So percentage of steel reinforcement 0.75, permissible shear stress is 0.34 Newton per mm square. So 1.37. So by method of interpolation calculate permissible shear stress for this much of steel reinforcement percentage. So permissible shear stress is equal to 0.352 Newton per mm square. As permissible shear stress is less than maximum permissible shear stress, so permissible shear stress is 0.352 as per problem, but maximum shear stress maximum permissible shear stress as per IS code is 1.6 Newton per mm square, which is more than this, so our design is okay. Now in problem, nominal shear stress is greater than permissible shear stress. So shear reinforcement is required. Design shear force. So here nominal shear stress is 0.59 and permissible is 0.35. so nominal shear stress is more, so shear reinforcement is required. If the equation is like this, then shear reinforcement is good. Now we are designing the shear reinforcement. Shear reinforcements in terms of stirrups. Design shear force for shear reinforcement is equal to Vs is equal to V minus permissible shear stress into B into D. So V is equal to 104.1 into 10 raised to 3 minus 0.352 into 300 into 585. So 42.32 into 10 raised to 3 Newton. For this shear stress we need shear reinforcement. So provide two-legged stirrups of 8 mm diameter of Fe 250 grade steel. So then spacing of stirrup. So here this is assumption. You can assume 10 mm diameter bar. So any type of diameter bar you can assume, but it affects on the distance only. So spacing of stirrups S is equal to SV is equal to, that is shear reinforcement. Spacing for shear reinforcement. That's why sigma SV into ASV into D divided by Vs, which is equal to 140 sigma SV 140 shear stress in permissible shear stress in steel and permissible shear stress in concrete. So SV in C, area of steel provided into depth, effective depth divided by Vs. That this is Vs, that is design shear force. 140 into 2 into pi by 4 into 8 into 8 into 585 divided by 42.32 into 10 raised to 3. So it's D ASV pi by 4 into 8 square divided by 2 140, so 194.5 mm. That is the spacing of stirrups. Now provide 8 mm diameter two-legged stirrups of Fe 250 grade steel at 190 mm center to center. So it is, so this is the shear reinforcement which we calculated. Now we'll check as per IS 456. So now as per IS 456, minimum shear reinforcement in the form of stirrup should be such that ASV divided by B into SV should be greater than 0.4 divided by 0.87 into Fy. So SV is equal to 2 into pi by 4 into 8 into 8 into 0.87 into 250 divided by 0.4 into 300. So rearrange this equation for SV. So it is 182.21 mm. SV should not be greater than 0.75 into effective depth, 438.75 should not greater than, and SV should not be greater than 300 mm. So use lesser value from these three. So as per IS 456, shear reinforcement in terms of stirrup, so spacing should be lesser than these three. Adopt 8 mm diameter two-legged stirrups of Fe 250 grade steel at 180 mm center to center. Earlier we have decided 190 mm, but as far as your IS code is concerned, IS 456 is concerned, these three conditions should be satisfied. So here we are providing shear reinforcement is 180 mm center to center. So this is the shear reinforcement, or for this we have designed our beam. So if you like the video, please do share it and subscribe the channel. So more and more such fruitful videos I am going to upload, so you will get the knowledge. This is the design of beam. Now I have uploaded videos of designs of RCC, designs of RCC beam, RCC column, RCC footing, RCC slab. So if you study this, you will get the design of whole building. Now I am interested to upload a video based on the design of complete building based on this tutorial. So this is the practical example I am going to upload in coming days. So be aware, please watch the videos. If you like it, please do share it and subscribe the channel. Thank you. Enjoy the learning.